All right, in 5 short slides, I am going to briefly explain the circulation of the atmosphere. All right, so global atmospheric circulation. There are 3 main cells, and we can see them listed below. One is the Hadley cell, 2 is the Ferrel cell, and 3 is the polar cell. Hadley cell features air rising near the equator, and I'll show it on the next picture. Air is rising up and coming up to the poles, and then descending in the subtropics when returning equatorward toward near the surface. Ferrel the Ferrel cell is average motion of air in the mid-latitudes, characterized by sinking air and rising air farther poleward. At the surface, air flowing poleward is deflected to the east by the Coriolis effect force, resulting in westerly surface winds. Now, the polar cells, which are the third one all the way to the left, polar cells are located near the Earth's poles, both north and south, and are the last cells. The cold air falls and travels inward toward the equator. Okay. Now, on this slide, we have a good picture of where the equator is and then where the Hadley cell would fall. You can see the red arrow on the upper cell. The upper and lower, they're both Hadley cells, but looking at the upper one, you can see that air is rising, hot air is rising up and going all the way toward the poles and coming down into the subtropics, and this produces winds called the trade winds and the tropical easterlies as well. All right, so here is another really good picture of what the air does to clouds as these cells circulate and as the air circulates around. So in that Hadley cell, you can see you got a big funnel type tall cloud coming up being produced from these Hadley cell circulatory winds. And then next, if you look to the Ferrel cell, you can see that it's more clumpy of a cloud, and wind is actually rotating the opposite way. It is very important to see which way the wind is rotating. And then on the polar cell, we see the wind is rotating counterclockwise and also the direction that is taking. Now, we look at this picture, and it is global atmospheric circulation. This kind of shows all the arrows and the directions that these cells cause wind to travel. And wind is all over the place. It is moving in clockwise, counterclockwise, everything. And so if you see, this is the movement of air across the planet. Circulation creates winds across the planet that leads to areas of high rainfall, like the tropical forest, and areas of dry air, like the deserts as well. So this is just moving air across the whole entire Earth, habitable Earth. Alrighty. Now here is one of my last slides. This is showing the Coriolis effect and how the Earth's tilt affects the way the wind moves and the direction of the wind. And you can see where that slant is in the Earth. And then if you look and read on the side, you can see where the westerlies are located in the upper left, and then the polar easterlies, and how those winds collide at the Arctic Circle. And then you can also see where the trade winds are, which is along the equator, and then the prevailing westerlies and the polar easterlies, those are all near the poles, which is really cool. And you can also see where wind deflects and where wind is directed and everything. So the results of Earth's rotations on weather pattern is very interesting and causes a big change to the Earth. Whereas if it was just straight up and down and there was no tilt to the Earth, then the winds may appear a little bit differently. Alrighty, the end. That is all I have for global atmospheric circulation.